19.1 has a homework assignment, and portions of the homework assignment are not included in our curriculum. So I'm going to go through and do the problems that we are including in our curriculum, and I'll let you know which ones you are not responsible to know. So we are going to talk about the term counterexample. We are going to look at all the natural numbers, rational numbers, real numbers, whole numbers, integers, irrational numbers, and we're going to arrange them in a Venn diagram. So for question number 2, I want to list all the numbers that are indicated in the given set. And the given set is a set of whole numbers. If I write the set of whole numbers in set notation as a set of numbers, the set of whole numbers begin with the number 0, then the number 1, then the number 2, 3, and so on. One way you can remember that is the letter O is in the word whole. So they start with the number 0. So negative 9 is not in the set of whole numbers. 18 is in the set of whole numbers. 1 is. 3/4 is not. 0 is the first whole number. 92, yes. Radical 7, no. And no. So we see no decimals, no fractions, no radicals that are irrational. No non-perfect squares. The set of rational numbers. Rational numbers are numbers that can be written in terms of A divided by B. Something over something else. And we just have to remember that B could never be equal to 0. We can never divide by 0. So while 3/8 definitely looks like a rational number, negative 4/5 looks like a rational number, there are some other numbers here that are rational. For example, 8 can be written as 8 divided by 1. So that is a rational number. Negative 15 can be written as negative 15 divided by 1. That is a rational number. As is 3/8. 0 over anything, 0 over 2, 0 over 4, is a rational number. Radical 3 is not a rational number because the square root of 3 is a never-ending decimal. It goes on and on and on. And so far, the decimals that you've seen, the decimals and fractions that you've seen are all ending decimals. 9.5 is a rational number. If I write 9.5 as 9 1/2, that's the same as 2 times 9 is 18, plus 1 more is 19 divided by 2. So 19 divided by 2 is a rational number. It can be written in terms of A over B. Negative 4/5 and 857 divided by 1 is also rational. So the only one there that's not rational is radical 3. That's an irrational number. It's a non-perfect square. Real numbers are all numbers in our number system that are not imaginary numbers. So every number listed there is a real number. So we're going to include all of those in the set of real numbers. All right. So we are not interested in this course in number sets that are closed and not closed. So I'm going to jump ahead. We're going to go and pass up these questions. And we're going to head to question number 13. We're going to use the given equations to answer each question. But in order to use these equations, I need to solve them. So next to each equation, I'm just going to put the answer for x and solve each equation. Number 14 says, which equations from above would you solve if the only numbers you knew were integers? So if I just have the list of integers to use to solve each equations, I could use the set of integers to solve equation A because 6 is an integer. 0 is an integer. Again, 6 is an integer. Negative 5 is an integer. Negative 4 and positive 4 are both integers. 0 is an integer. 1 is an integer. Sometimes what's helpful is to list the set of integers to give you an idea of what numbers are included. Which equations can I solve if the only numbers I have are real numbers? Every equation up above has an answer that is a real number. So if I only had real numbers to select for these answers, I can use any of those. We're not going to require that you can change a decimal into a fraction in examples like this where we have repeating decimals.